Welcome to this lesson on the relationship between chemical bonds and energy changes in chemical reactions. In today's lesson, we will introduce the concept of bond breaking and bond forming in chemical reactions and how these processes are associated with energy changes. By examining these processes, we will advance our chemical understanding of energy transfer during reactions. This will provide us with a clearer picture of why chemical reactions behave the way they do and how they are harnessed in real-world applications. In a chemical reaction, the reactant molecules must come together and undergo changes to form new products. This involves two key processes: bond breaking and bond forming. To understand this, let's consider a simple analogy. Imagine you have a set of building blocks connected together to form structures. To rearrange these blocks into new structures, you first need to disassemble the existing ones, which illustrates bond breaking, and then reassemble them in a new configuration, which is bond forming. Let's take a look at these stages in more detail. The first step in most chemical reactions is to break the chemical bonds that hold the atoms together in the reactants. This requires an input of energy. Think of it as needing energy to pull the building blocks apart. The energy needed to break these bonds is known as activation energy. After the bonds in the reactants are broken, the atoms rearrange and form new bonds to create the products. This step releases energy because forming new bonds makes the system more stable. To sum up the energy changes in a chemical reaction, we need to consider both the energy absorbed in breaking bonds and the energy released in forming new bonds. The total energy change is the difference between these two amounts. If more energy is absorbed to break the bonds in the reactants than is released when new bonds are formed in the products, the reaction is referred to as endothermic. We'll return to this in subsequent lessons. Conversely, if less energy is absorbed to break the bonds in the reactants than is released when new bonds are formed in the products, the reaction is referred to as exothermic. We'll also return to this in subsequent lessons. Before we conclude, let's consider a historical note for chemical bonds as an extension task. The modern understanding of chemical bonds was hugely influenced by two brilliant scientists in the early 20th century, Gilbert N. Lewis and Linus Pauling. Gilbert Lewis was the person who introduced the concept of electron pairs forming bonds, which helps us understand how atoms stick together. He also created the famous Lewis dot structures that show how these bonds work. Then came Linus Pauling, who was able to expand on Lewis's ideas. Pauling's research on electronegativity explained why some bonds are stronger than others and why molecules have specific shapes and properties. His book, The Nature of the Chemical Bond, published in 1939, is considered one of the most influential chemistry books of the 20th century. Together, their groundbreaking work laid the foundation for everything we know about chemical bonding today. In today's lesson, we delved into the relationship between chemical bonds and energy changes in chemical reactions. We highlighted the concepts of bond breaking and bond forming, key processes that are integral to every chemical reaction. This foundational understanding of energy changes is essential for the material covered in our next lessons.